Let's look at integration by parts of definite integrals. If we let u equal a function f of x and v equal a function g of x with continuous derivatives over an interval from a to b, then the integral of u dv from a to b is equal to uv evaluated from a to b minus the integral of v du from a to b. Notice that this is very similar to using integration by parts to find an indefinite integral, but we just added limits of integration. Remember that when trying to choose the expressions for u and dv, we can use LIATE. Recall that LIATE stands for logarithms, inverse trig functions, algebraic expressions, trig functions, and exponential expressions. This means that we first want to pick an expression for u by starting at L and working our way down to E. Then, the remaining expression can be used for dv. Now, let's use integration by parts to evaluate a definite integral. We need to choose what to use for u and what to use for dv. Let u equal x. So, du is equal to dx. That means we set dv equal to 1 over the quantity x plus 4 squared, or the quantity x plus 4 to the negative 2 dx. Integrating, we get v is equal to negative 1 over x plus 4. Let's substitute these into our formula for integration by parts for definite integrals. We get negative x over x plus 4 evaluated from 0 to 4 minus the integral of negative 1 over x plus 4 dx from 0 to 4. We won't evaluate our first term yet, so integrating, we add the natural log of the quantity x plus 4 and evaluate it from 0 to 4. Evaluating the first term, we get negative 4 over 8, and in the second term we get the natural log of 8 minus the natural log of 4. Simplifying and applying the difference property of logarithms, we get negative 1/2 plus the natural log of 2.